Alright, so I'm going to start right at the top of page 222. Welcome back. We're jumping right back into circles with some theorems that help us find missing sides and missing angles. So, theorem 6.13, I'm right at the top of page 222. I just want to say this really quickly. Next week in class, I'm not going to go over this stuff. It's very important that you pay close attention now. And if you have any questions, you let me know. Call, text, tweet, email, pause, rewind, find a way to understand this, because when we come back to class, I might go over one question. I'm just going to put an X ticket in front of your desk, and we're going to go. So, theorem 6.13. It says that the tangent and the chord intersect at a point on the circle. Then the measure of each angle formed is 1/2 the measure of the intercepted arc. Sounds really confusing. I promise you it's not. So, I have this tangent line A. You know it's a tangent line because it only intersects the circle at one point. And then it actually is intersecting with this chord, BA. So there's two angles formed now. Angle 1 and angle 2. And when I'm talking about angle 1, I'm talking about the angle between the chord and the tangent. If I want to find the measure of angle 1, the first thing I have to do is find the measure of this intercepted arc here, this arc BA. If I know the measure of that arc BA, the measure of angle 1 is just going to be 1/2 times that arc. So down here where it says the measure of angle 1 equals, well, the measure of angle 1 equals 1/2 times the measure of arc BA. The same deal holds true for this second angle, measure of angle 2. If I want to find the measure of angle 2 here, the first thing I need to do is find the measure of this big arc, BCA, that major arc, BCA. So, if I know what the measure of arc BCA is, to find out the measure of angle 2, I just take that arc measure and divide it by 2 once again. So the measure of angle 2 is 1/2 of the measure of arc BCA. So, if it's still confusing, hold on. When I go through this example, it's going to be crystal clear. So, let's come down to example 1 right below. So, for example 1, I'll scroll up. So, it wants us to find the measure of angle 1, for example, for part A of example 1. So, I see angle 1 is this angle down here. It's the acute angle at the intersection of my tangent line and my chord. Well, luckily, I know what the measure of this arc BA is. So, the measure of this arc here is 132. The way I think about it, the way I don't get it confused, is because I know I have this big arc and I'm coming down to the small point to find this angle. Big old arc coming down to the angle. I'm going to take that 132. To find the measure of angle 1, I'm just going to divide this 132 into 2 equal parts. 132 divided by 2 is going to give me 66. The measure of angle 1, that's just going to equal 132 divided by 2, which is 66 degrees. Just 66 degrees. I'm going to come down so you can see what that looks like when you fill it in. So down here it says the measure of angle 1 equals what times 132? Well, we know the measure of angle 1 equals 1/2 times 132. And 1/2 of 132 is just 66 degrees. So that's your answer for part A. Let's take a look at part B. So I have it to not want to erase quickly. Then I realize you're on the computer, so you can just pause it. So, let's look at this part B. I'll blow it up once again so you can see it. Okay, so for part B, they want us to find, this time, they want us to find an arc. They don't want us to find an angle. You can see this. They want us to find the arc measure of EFD. From E, we're on to F, to my angle. I think going from big to small, I'm going to divide. Now I have just this angle, the measure of this one point here, this angle, and I want to find the measure of this big arc. I'm going to multiply by 2. So what this looks like, so you can fill in your notes. So the measure of arc EFD is going to be what times 110? Well, we know we're actually going to multiply. So it's going to be 2 times 110. That entire arc measure there is 220 degrees. Just that simple. So, last check. Everybody scroll down to where it says checkpoints right below this. We're going to see what you know. Looking at question 1 under checkpoints, still on page 222. It wants us to find the measure of arc ACB. That's the arc that goes from A over to C, back around to B. So we know the angle where the tangent line intersects the chord is 120 degrees. We just have to find that intercepted arc. I want you to press pause and try this on your own. When you're ready, I'm going to go over the answer. So now that I know this angle is 120 degrees, I'm going from the small point where my angle is out to this big old arc. I'm going to find out what this big old arc measure is. So I'm either going to divide by 2 or multiply by 2. Since I'm going from this small point to the bigger arc, I'm going to multiply by 2. So my answer is just going to be 120 times 2. 240 degrees is the measure of arc ACB. Alright? So, now that you've seen that, I promise, and I told you that it wasn't going to be that difficult. Here's what I want you to do for practice, and I'm going to check this when you come back. I want you to go over to page 225, work questions number 1, number 2, number 3, and number 4. Should only take you about 30 seconds each. And then flip over to page 226. I want you to work questions number 18 and 19. 19 is going to be your challenge question, extra credit for anybody who can come up with the correct answer for number 19. Alright, that's the first video I'm going to watch. I'm going to do one more video that's going to teach you the second property